In this video, I'm going to go over the basic composition of the atom. So in terms of, if you're looking at just one atom, right, there are two distinct regions. The nucleus, which contains the protons and the neutrons of an atom, and the region around it, right, is just a region of negative charge surrounding the nucleus, and the electrons fill this space. So in terms of the three different subatomic particles, those are the ones that we're really going to focus on, okay? The proton and the neutron are the same mass, essentially the same mass, about 1 AMU, or atomic mass unit. And an electron is about 5.4 times 10 to the minus fourth AMUs. Okay, so just to put that in perspective, if you have a proton and a neutron, those are essentially the same size, right? Essentially the same size, whereas the electron is 4 orders of magnitude times smaller, right? 10,000 times smaller than a proton or a neutron, okay? And then the charge on each of them, so a neutron, as you might guess based on the name, is actually neutral. It does not have a positive or negative charge. A proton is a positive charge, and an electron has a negative charge, okay? So within a nucleus, each atom will have a set number of protons, okay? And the set number of protons distinguishes what kind of element that atom is. All right, so it actually doesn't matter how many neutrons it has, right? That will actually change up depending on the isotope, right? But the protons, the number of protons, are essentially like the ID number for an element. That is to say, if you have an unknown atom, right, and if you had 15 protons inside the nucleus of that atom, you have always and forever a phosphorus atom. It does not matter how many neutrons you have in that nucleus as well. If you have 15 protons, you'll always have a phosphorus atom. Now, how did I know that? It's because the proton number is also the same as what we call the atomic number. And the atomic number is the whole number that we see on the periodic table that tells us how many protons each one of those atoms has. Okay, so that means that the phosphorus atom, to go back to my example, the phosphorus atom has 15 protons. That means it has 15 positive charges, if you will, inside of the nucleus. Okay, now if we have a neutral atom, that neutral atom would dictate that we would also have 15 negatives, because 15 plus 15 minus equals 0, and that results in a neutral atom. Okay, so anytime we have a neutral atom, the protons and the electrons will balance one another out. Now the mass number is another number that we'll also need to keep in mind when we're looking at an element on the periodic table. Okay, now remember I said that the protons and the neutrons are the same mass, while the electrons are essentially negligible mass when compared to protons and neutrons, right? The mass of an atom all depends on how many protons and neutrons are in the nucleus. That is to say, the nucleus contains the vast majority of the mass associated with an atom. Okay, so the mass number is actually the number of protons plus the number of neutrons associated with that particular atom. So by using both the mass number and the atomic number, we can actually subtract the atomic number from the mass number to determine how many neutrons are in that atom.